Hi class, this is Professor Smith. I'm going to be doing problem number 18 on sample test 3 on chapters 5 and 6. In this example, we're asked to find all solutions to the equation root 3 cotangent theta minus 1 equal to 0. Similar to the last problem, we want to isolate the trig function. We want to isolate, in this case, cotangent theta, which means to get it by itself. So if we add a 1 to both sides and divide by root 3, we'll have cotangent theta equal to a constant. I've opened up math type to capture what we would write on a piece of paper. Since the cotangent of theta is equal to 1 over root 3, we know that the tangent of theta is equal to the reciprocal of 1 over root 3, which is just root 3. So we have the tangent of theta is root 3. So now I'm going to open up Word to draw an axis, including the angle, so we can see what special triangle has a value of root 3 for tangent. I know them for sine and cosine, but I don't have them memorized for the tangent function, but I can always use right triangle trig to derive or find that angle by using the special values. So I've opened up Word. I have the axes. I've drawn the angle in the first quadrant since tangent was positive root 3. And I know that tangent is opposite over adjacent, so that's why I have root 3 expressed as root 3 over 1. And then I say, oh, now I get it. I recognize this now. This here is a 1, 2, square root of 3 right triangle. And now I can determine theta. I know that a 30-60 right triangle will have the numbers 1 as the one side, root 3 as the other, and 2 as the hypotenuse. But since root 3 is larger than 1, this angle theta is going to be the larger angle of between 60 and 30. So this theta is equal to 60 degrees. And 60 degrees is the same as pi over 3. So now that we've found that, we know that our reference angle is going to be pi over 3. So we'll capture that in math type. Since our value is root 3, we have to ask ourselves, where is the tangent function positive? Root 3 is positive. So it's noticed that tangent of theta is root 3. So we have to ask ourselves, where is the tangent positive, given that we've got the tangent of an angle theta that's equal to a positive root 3. Well, the tangent is positive where the x and y have the same sign. In the first quadrant, x and y are both positive, so the tangent will be positive. In the third quadrant, x and y are both negative, so the tangent will be positive as well. So we have the tangent function is positive in quadrant 1 and in quadrant 3. So in order to find the value for the quadrant 3, we just add pi to the reference angle. So theta is equal to pi plus pi over 3. Getting a common denominator, 3 times 1, pardon, 1 times 3 is 3, plus 1 is 4, so we have 4 pi over 3. Since our reference angle is already in quadrant 1, we already know that theta is also equal to pi over 3. Those will give us the values if we're on the interval from 0 to 2 pi. But this one asks for all possible values. So we not only want the pi over 3, we also want the values for any multiple of pi over 3. So if we take pi over 3 and add 2 pi k, where k is an element of the integers, that would work. And we could do the same thing for the second angle that we got of 4 pi over 3. But then we notice something that's kind of cool. If we look at a picture back in Word, we begin to notice something that's kind of cool. So this is the second angle, here theta. We notice something really cool. This will give us, again, the same positive root 3 because we're going to get a negative root 3 and a negative 1. But I notice the difference between this angle, pi over 3, and 4 pi over 3. I think, hey, look at here. the difference between these two is just pi. So we could combine these two and write it as pi over 3 plus pi k. Take off the 2. And that will pick up all the values. So let's go ahead and submit that on ALEC. So I hope this movie on number 18 on finding all solutions to the equation root 3 cotangent minus 1 equal to 0 was helpful.